Types of angles. Angles can be grouped into types based on the measurement or the structure of the angles used for calculations or used for analysis. The first type of angle that we want to look at is the acute angle. So an acute angle is an angle that measures less than 90 degrees. Or you can see an acute angle is an angle that is less than 90 degrees. This means that when you measure acute angles, they are greater than 0 degrees as the first measurement of the angle. Angles begin from 0. So 0 means nothing. So acute angles are greater than 0 degrees, but they are less than 90 degrees. So there are angles which are greater than 0 degrees, but less than 90 degrees. Also, what we say is that acute angles fall within 0 and 90 degrees. That is to say, they are between 0 degrees and 90 degrees. That is also to remind us that 0 degrees is not an example of an acute angle, and then 90 degrees also is not an example of an acute angle. So if you measure an acute angle by diagram, let's say you take this diagram and you measure this and you get theta, where theta means an unknown angle. If theta is an acute angle, that means that theta will measure between 0 and 90 degrees. That is it. So examples of angles that are acute are, we can talk about 5 degrees, 22 degrees, 72.5 degrees, 90 is not part. So we can talk about 89.2 degrees. So from 0 to 90, the angles that are between 0 and 90 becomes what we call acute angle. So indeed, if you want to draw to represent acute angle, look at this. This is the angle that is starting from 0 degrees, and this is the angle that meets or that ends at 90 degrees. Now, if you get this, between this angle or between this range of angles, we have the acute angle. So the range of the acute angle is then given mathematically as 0 degrees, less than theta, and less than 90 degrees. That means that if this is acute, where theta is acute, if theta is acute, so where theta is acute, if theta is acute, then theta should be greater than 0 degrees, and that same theta should be less than 90 degrees. So this is the mathematical way of representing acute angles. Now let me draw some diagrams to represent acute angles. I can draw a diagram like this. This can be an acute angle. So you see the acute angle, they are not that all that wide. So just because they are not wider than 90 degrees, I can also draw something like this. This is also an acute angle. Then if I draw a straight line, and then let's say I demarcate the straight line. Now, let me put angle A here, and let me put angle B here. The angle A obviously will be an acute angle, because if you look at the measurement of A, it is not larger than 90 degrees. It will rather be less or smaller than 90 degrees. So then angle A becomes the acute angle. So that is all about acute angle. Let's take a look at the next type of angle. Right angle is an angle that is equal to 90 degrees. Yes, so right angles, anything right angle is equal to 90 degrees. It is because it measures up to 90 degrees exactly. Or if you are able to measure an angle and then you know that this is right angle, when you measure that angle, you should get exactly 90 degrees. That is the meaning. So usually the right angles are drawn to represent 90 degrees. So they put a symbol like this, and this is what we call the perpendicular symbol or the 90 degree symbol. So right angles are popularly referred to as 90 degrees angle. So right angles are popularly referred to as 90 degrees angle. That means all right angles measure equal to 90 degrees. Let's draw more diagrams to depict right angle. So if I draw a diagram like this, and then I put this symbol in there, it means the measurement here is 90 degrees. I can also draw something like this. Normally, you can't even, or you don't need to even bring the perpendicular symbol, but it still depicts right angle. So this one here is a right angle. So you can draw right angle in so many ways. Now, further ahead, there will be a topic called trigonometry. We'll draw the right angle and then we close it up to form a triangle. So then the name of the triangle will become a right angle triangle, meaning the 90 degrees interior triangle. So if the 90 degrees is inside the triangle, then one angle is 90 degrees. That is to say, one angle becomes right angle. So we call it the right angle triangle, meaning the 90 degrees triangle. But far from that, right now we are focusing on the angle itself, which is right angle. And right angles equal 90 degrees, or right angles are equal to 90 degrees. So let's now take some calculations around the right angle, or how we can use right angle to form calculations on diagram. If we take this diagram, we have the angle ABC measuring up to 90 degrees. Then we have demarcated the angle into two, so ABD. Let's put D here. So ABD as the first angle, L, represented with the variable L. And then DBC, 40 degrees. What does this say? It means the L combined with 40 will give you 90. So L plus 40 degrees is equal to 90 degrees. So if you want to find the value of L, it becomes L is equal to, we take the positive 40 degrees to the other side, that is the right hand side, to subtract because it crosses the equal sign. So 90 degrees minus 40 degrees. Then becomes L is equal to 50 degrees. What does that mean? It means if you are supposed to get the value of L, it will be 50. Now let's see whether that is true. Now if L is 50, it will be 50 plus 40, which is 90. So truly it is correct. Let's take another question. This question also depicts an angle 90 degrees with separation into two angles. It says find X. Now X here and the 2X here, when you combine, you get 90 degrees. So with this diagram, we say X plus 2X should be equal to 90 degrees. Now X and 2X, when you add them, you get 3X. So 3X is equal to 90 degrees. Then we divide both sides by 3, divide them by 3, divide them by 3. Then this 3 will cancel here 1, this will cancel this 1. So remaining with X. Now 90 divided by 3, 3 here 1, 3 into 90 as 30. So we get 30 degrees. So it means that the angle X is 30 degrees. Now, if 30 is here, 2X means 2 times 30, which is 60. And 30 plus 60 should give us what we call 90. So X as 30 and 2 times the X, which is 2 times the 30, as 60. And then 30 plus 60 gives us what? 90. So the angle there is 90 degrees. Let's take another example. This will be our third example for the right angle. Now in this diagram, XOZ is a diagram with XO as one line, YO or OY as another line, ZO. Now the angle from XOZ is 90 degrees, but angle XOY is R and angle YOZ is also 70. Now from this is clear that when we add R and then 70, we will get 90 degrees. So it becomes R plus 70 degrees is equal to 90 degrees. Then we make R in the subject by taking positive 70 across the equal sign to the right hand side to become negative. So it becomes R is equal to 90 degrees minus 70 degrees. So we get R is equal to 20 degrees. So if we should get R as 20, now let's confirm. Now R is 20, so 20 plus 70 will give us 90. So that means it is correct. So don't forget that right angles equal 90 degrees, or a right angle is an angle that measures equal to 90 degrees. The next one, which happens to be a third one, will be the obtuse angle. Now obtuse angles are angles that are greater than 90 degrees, but they are less than 180 degrees. That means obtuse angles measure between 90 and 180 degrees. 90 degrees is not an obtuse angle, and 180 degrees is also not an obtuse angle. So if an angle measures greater than 90 degrees, but rather less than 180 degrees, it becomes an obtuse angle. That means anybody who has obtuse angle can get examples like 95 degrees, 100 degrees, 120 degrees, and even 180 is not parts. So we can talk about 170 or 179 degrees. Now, if you check those angles, they are called obtuse angles. The range of angles that will form obtuse angles will begin not from 90 degrees, so we should note that, but rather will begin above 90 degrees, but rather will end not on 180 degrees also, but end close to 180. That is to say, the range can be represented in mathematics as 90 degrees less than theta, theta less than 180 degrees. That means that theta is an obtuse angle. So if theta is an obtuse angle, it is trying to tell us that this theta is greater than 90 degrees, and also this theta is less than 180 degrees. So obtuse angles are greater than 90 degrees, but less than 180 degrees. By diagrams, we can draw this as an obtuse angle. It is very wide in terms of its measurement. So theta is an obtuse angle. We can also draw something like this as an obtuse angle. So this is an obtuse angle. And then let me just show you something. If I should draw this as a diagram and I put x here, I put y here, and then I ask a simple question. X and y, which one is the obtuse angle? We all choose y because y is greater than 90 degrees. That makes it obtuse angle. By measurement, it will still be less than 180 degrees. So obtuse angles are angles that are greater than 90 degrees but less than 180 degrees. Type of angle, which happens to be a fourth type of angle called straight angle. Now, straight angle, as the name goes, is an angle formed on a straight line. So another name given to straight angles will be straight line angles or angles formed on straight lines. Now, straight angles measure up to 180 degrees. So if you have a line like this, it means that half of that particular measurement of the angle on the line is 180 degrees. So this is a straight angle. So if we talk about angles on a straight line, then we can talk about, let's say, two or more angles formed on a straight line. That one will now be called adjacent angles. So let's say A, B, C are angles which are adjacent to each other. They are adjacent because they are side by side to each other. And since they are on a straight line, they will become angles on the straight line. This means that the A plus B plus C will be equal to 180 degrees as an angle. So this character is referred to as angles on a straight line. Now this character has the same as an angle referred to as adjacent supplementary angle. Further in our video or in this course, we will study something called supplementary angles. Then we'll come to realize that supplementary angles sum up to 180. And adjacent angles are angles that are just sideways or that are beside each other. So when I draw a straight line and I have, let's say, x here and y here, since x and y are just separated by a line and they are directly beside each other, they are referred to as adjacent angles. So the adjacent here means that they are side by side to each other. And then if they become supplementary, it means that they sum up to 180. So the name that we can give to them is adjacent supplementary angles, meaning x plus y should be equal to 180. And since it has the same character as a straight angle, then we can also say that straight angle or angles on a straight line are also referred to as adjacent supplementary angles. They both have the character that sum up to 180. Now let's take a look at straight angle calculations. That are some calculations around the angles in a straight line or the straight angle. If I have a diagram like this and then I put A here, I put 70 degrees and I put 80 degrees here. That means that the angles here must add up to 180 degrees. So then I will calculate it this way. A plus 70 plus 80 should give me 180. So A plus 70 degrees plus 80 degrees should give me 180 degrees. Because they are angles on a straight line, so they should sum up to 180. Now, now 70 plus 80 will give us 150 is equal to 180 degrees. Now, we will take the 150 which is positive to the other side to go and subtract from the 180. Also, we get A is equal to 180 degrees minus 150 degrees. So if we subtract, we get 30 here. So A is equal to 30 degrees. That means the value of A is 30. Now when we bring 30 and we add it to 70, we get 100. 100 plus 80 becomes 180. So that means that indeed this solution fits the question. So that is that. Let's take another example. This one says find the value of x in this particular diagram. Now we can see the straight line here. So these angles that are formed adjacent to each other on the straight line will sum up to 180. So we have 60 degrees plus x plus 80 degrees should be equal to 180 degrees. Now 60 plus 80 will give us 140. So x plus 140 degrees is equal to 180 degrees. So that will take positive 140 to cross the equal sign to the right hand side to become minus 140. So x is equal to 180 degrees minus 140 degrees. So we end up getting, therefore, x is equal to 40 degrees. So the value of the x in this particular question is 40 degrees. Let's now substitute and see whether it's correct. When we put 40 here, 40 plus 60 will give us 100. And 100 plus 80 will give us 180 degrees. So that means that it confirms the value of x to be 40 degrees. Remember, angles on a straight line should add up to 180 degrees. Let's take another question. This third question reads, find the value of y. Now if you check this diagram, if you don't take care, you'll be a little bit confused. But check, AB is a straight line, and then CD is a straight line. If this were to be a well-structured question, you realize that in questions like that, they will describe everything going on in the diagram for you. But this is just an illustrative example. So let's describe it to ourselves, and then we proceed to answer the question. Since CD is a particular straight line, that I have y plus 20, this binomial angle on this line, and also another binomial y plus 10. You realize that the two angles are on that straight line. So they are angles on a straight line, or they are straight line angles. So they add up to 180. That means that the y plus 10 degrees plus y plus 20, those two angles should add up to 180 degrees, or should give you 180 degrees. Now there's 1 in front of the bracket, so we just open the bracket with a 1. 1 times this number is the same number, so y plus 10. Y plus 20 has 1 in front of it, so 1 times this whole thing becomes the same thing. Y plus 20 is equal to 180 degrees. So let's go. Now if we group like terms, y plus 10 plus 20 is equal to 180 degrees. Now y plus y is 2y. 10 plus 20 is 30. Is equal to 180 degrees. Now let us take positive 30 to the other side to become minus 30. So it becomes 2y is equal to 180 degrees minus 30. We take positive 30, which is a constant. When it crosses the equal sign to the right hand side, it will change to negative. To join a constant 180, so it becomes constant 180 minus constant 30 degrees. Now 180 minus 30 is 150. So you get 2y is equal to 150 degrees. Then we divide both sides by 2. So it becomes 2y is equal to 150 degrees. We divide here by 2, then we divide here by 2. 2 here cancel itself 1 and cancel this one. So remaining with y, which is also equal to 2 cancel itself 1. Then 2 cancel 150, 75. So we end up getting y is equal to 75 degrees. So the value of y in this diagram is 75. When you add 75 to this, you end up getting 85 here. Then when you add 75 to it, you end up getting 95. Now 85 plus 95 will be 180. So that means it has confirmed that that is the answer. Let's go to the next type of angle. Will be the reflex angle. So this will be my angle number 5. So reflex angle can be angles that are greater than 180, but rather they are less than 360 degrees. So that means that if you measure reflex angle, you are going to get angles between 180 degrees and 360 degrees. That means reflex angles cannot be 180 degrees, or 180 degrees are not reflex angle, the same as 360 degrees are not reflex angle. Just that the reflex angles are rather between 180 and 360 degrees. So mathematically, we can say reflex angles can be represented as 180 degrees less than a theta and a less than 360 degrees, where theta is a reflex angle, meaning that this theta represents a reflex angle. So with this particular mathematical representation, you realize that the reflex angle is greater than 180 degrees, and that same reflex angle rather is less than 360 degrees. That is a reflex angle. So let's see the way that we can draw reflex angle by diagrams and give some examples. So when we draw reflex angle, for example, I have this angle. You see, within it is an acute angle, but just away from it or outside it or down there will become the reflex. So this is how reflex angles are. In fact, reflex angles are actually acute or obtuse angles which are taken from the other side. So if let's say the obtuse angle is here, you ignore that and then take it from the other side. That becomes your reflex angle. So another example is this. So this one here is the angle, then the reflex angle is here. So that becomes a reflex angle. And actually, examples of reflex angles could be 190 degrees, 270 degrees, 280 degrees, 300 degrees, even 320 degrees can be a reflex angle, and then 359 degrees can be a reflex angle. So far as the angle is less than 360 degrees but also greater than 180 degrees, it becomes a reflex angle. So please take note of that. Angles at a point will become my number 6 type of angle, even though that will not be the last one, but that will be angle number 6. Now, angles at a point are referred to as angles in a circle. That means that those angles, when you see them at the point, when you sum up the two angles or as many as they are, if you add them up, you should get 360 degrees. So angles at the point or angles in a circle are equal to 360 degrees. Let's take a diagram like this. I have this diagram here. You see, I have angle A, angle B, and angle C. You can see that they are formed at a point, or better still, they are formed around a circle or inside the circle. This depicting the circle shows that the angle should add up to 360. So when you take A, you add up to B, and add up to C, you should get 360 degrees. This makes this type of angle very easy to be calculated for. So we can put it in calculations or in diagrams that we can calculate for a particular angle. So for example, if I should give you an angle, let's say, now let me put A here, B here, C, D, E, F, G, H. All these angles must be able to sum up to 360 since they are formed at a point. So A plus B plus C plus D plus E plus F plus G plus H is equal to 360 degrees. So if I want to calculate something from these angles at the point, let me take three angles. So let's say I put 100 here. Then I put, let's say, 170 degrees here. Then I put X here. It means these three angles must add up to 360 degrees. So then I'll say X plus 100 plus 170 degrees should be equal to 360 degrees. So 100 plus 170 become 270 degrees. So X plus 270 degrees is equal to 360 degrees. Then I'll take positive 270 to the other side of the equal sign to go and subtract from the 360, since if the positive crosses the equal sign, it becomes negative. So it becomes X is equal to 360 degrees minus 270 degrees. So when I take 370 degrees, when I take 270 from it, I'll get 90 degrees. So it becomes, therefore, X is equal to 90 degrees. So the value of this X is 90, because when I add 90 to this, I'll get 190. Then I'll add it to 170, I should get 360 degrees. So that is how we actually deal with angles at the point, or also referred to as angles inside the circle or angles around the point. So lovely one, at this point, if you are going through well with me on this plane geometry 1 topic as we talk about angles, you realize that some of the angles are a range of angles, or they are greater than a particular value or less than a particular value. So we can talk about acute angles being greater than 0 degrees but less than 90 degrees. We talk about obtuse angles being greater than 90 degrees but less than 180 degrees. We talk about reflex angles being greater than 180 degrees but less than 360. So this range of angles are different type of angles. You realize that their description depicts particular angles which can be calculated for, but normally they are described to get the structure of the angle. But if you take equal angles such as right angles which are equal to 90 degrees, we take angles on a straight line or straight angles which are equal to 180 degrees, we take angles at a point or angles in a circle that are equal to 360 degrees. These angles actually are equal to a particular value, that is the value that they measure. So in view of this, we can use them to undergo calculations on diagrams. So please take this particular part and then use it to distinguish between the angles as we proceed to look at more character of angles that form the types of angles.